Hello, I'm Ian Coley, the General Manager of High Performance Computing at AWS. Recently, I had an interesting / slightly harrowing discussion with my teenage son. He said, "Dad, what exactly is it you do at Amazon?" He said, I think I get the cloud thing, but when I was searching YouTube videos for you, that's when it turned harrowing. He said, "You kept talking about this high-performance computing stuff. What exactly is that?" So for Vance and for all of you, here's how we think about HPC. High-performance computing is all around us. It's anywhere from the design of the automobiles that we drive, helping to improve the fuel efficiency, as well as helping to optimize autonomous vehicle simulations for autonomous workloads. It's in the retirement funds that we have, helping us to calculate what is the risk associated with the portfolio that we've invested in. It's in the weather prediction models that our weather services use, where they're trying to determine the path of destructive hurricanes and wildfires, as well as in businesses that are trying to predict the possible weather impacts upon transport, which many of you have experienced as you were trying to get here with some of the various weather challenges of the airports, or on commodity prices due to the impacts of weather on crops. And HPC also is involved in biosciences, helping to calculate the next generation of breakthrough drugs. So as you can see, whether we're actively aware of it or not, the outcomes of high-performance computing workloads are all around us. So when I started at Amazon a little over 2 years ago, I had the unique opportunity of starting right before the annual supercomputing event, which precedes reInvent by 2 weeks. So it was quite the trial by fire and drinking from the fire hose as far as meeting with customers and tons of meetings. But over the period of that less than a month, I had so many engagements and so many opportunities to hear directly from our customers about what they loved, how they loved the scalability, the elasticity, the on-demand capabilities, but also the challenges they were having, how some of the workloads couldn't perform on HPC, how it was difficult for them to think about how to even orchestrate their clusters, and how many of them just weren't even sure about where to start. So as we talked to those customers, we took that feedback because one of the key mechanisms I learned as I joined Amazon was our working backwards process. And what we do a little bit differently than other technology companies is that Amazon, rather than us go off in a lab and cook off something we think is really cool and then say, "Surprise, here you go, figure out how to use it," everything we design starts with working backwards from a customer problem, a customer issue, a customer desire, somewhere where a customer is not able to achieve something that they'd like to. And we take that back and that input, and that's what drives us to create the services and solutions that we do for you. So as we work through that working backwards from hearing all those feedbacks, the two categories of areas where customers were having challenges and we needed to do better broke down into technological as well as operational. So on the technology side, it was basically the standard components of any HPC cluster: compute, network, storage. Across the board, we had to do better. We had to develop better performance solutions and options for our customers. And then orchestration. So on the usability side, how did they know that they were able to control their costs? How did they know that their data was secure? How did they even think about getting their data into AWS from their large on-prem installations? And what we've done over these last 2 years is really gradually work off each of those. So we had those, starting with the technology, we had those areas where customers were blocked, and we've addressed them. We've addressed the networking, we've addressed the compute, we've addressed the storage, and we've addressed the orchestration. So let me back up a little bit, though, before we talk about how we got here I like to say where we came from. Because for those of you that are newer to HPC on AWS or AWS in general, the transformation in just the instance capabilities is staggering. 2006, 1.7 gigahertz was the processor that you could get on an instance. Whereas now, with our Z1D instances, you can get an industry-leading 4 gigahertz sustained. That clock speed is unparalleled anywhere on any cloud. As well as the high memory instances. Take a look at what you could get in 2006. Okay, less than 2 gigs of RAM. Today, on our X instances, 24 terabyte for those high memory workloads, SAP, HANA, or others, that can really benefit from that huge memory footprint. So how did we get there from 2006 to here? And one of those significant improvements was the commitment we made in radically re-architecting our infrastructure. As you can see, in 2012, our host architecture, 30% of that underlying machine was occupied by the virtualization technology. So you, as a user, were limited to only being able to perform workloads that use the remaining 70%. So we knew that that was too much and wasn't acceptable to the things we wanted to do in the future, especially for these demanding high-performance computing workloads. So you can see in 2013, we started moving things off. We still had that overhead, but we laid the groundwork by moving the networking and the storage, and then the real large jump came in 2017 with the introduction of our Nitro Architecture, which was a separate daughter card on the system that completely offloaded that virtualization technology, allowing you and your users to then take full advantage of the full CPU and memory of the hardware that you were running on. And then in 2018, we had customers that said, you know what, I get that that's a thin, lightweight hypervisor, but my workload is so demanding, and in fact, I want to see so much visibility into what exactly is going on that machine that I don't want a virtualized offering. I need a full bare metal instance. So we provided that last year. But what else has Nitro enabled us to do? It's allowed us to rapidly innovate on the networking side as well. So it's not just that ability to get you back the performance of the underlying compute hardware, but it's allowed us to innovate on the networking side. So you can see the C5 instances that we released in 2017. The performance was around 25 gig throughput. But by being able to add a second card with our C5Ns, we've now increased that throughput to 100 gigs. Not only that, but when you look at the packets per second, which many of our customers' workloads deeply care about, it's over a 200% improvement between C5 and C5N. And we're not done here. We're going to continue to innovate over the next year and continue to push that packet per second up, continue to push that bandwidth up. And as we jump to the compute side, as far as overall possibilities, this has enabled us with this Nitro architecture, with the network improvements, the computer improvements, to offer you a vast selection of 270 instances that you can then provide to your customers for your unique workloads. But some people look at that 270 and they say, whoa, thanks, but that's a little overwhelming. How do I know what's specific to my workload and how can I best perform what I need? So one of the areas what I'd like to talk about is kind of the workhorse of our HPC offering, and that is the C5N with 100 gig networking and the Elastic Fabric adapter, which I'll talk about in the future. One of the customers that we've seen that has really taken advantage of the C5N architecture has been Formula One. And for those of you that attended the Monday Night Live, you got to hear the Formula One speaker and see some really amazing graphics. And if you weren't able to attend, please look for it on YouTube. It's really amazing. What they're essentially doing is, with Formula One, they talk to their customers, which is their fan base, and they said, how can we make this a better product for you? And what they saw was the customers were looking for much more competitive racing in what they call wheel to wheel, where the racers are going, trying to pass each other. And what they figured out was that the drag from the car in front to the car behind was so intense that just being a second behind that lead driver, you were buffeted, and your push on the ground was 40% less than the lead driver, which is an incredible advantage to be in the lead there because you're disrupting that airflow so intensely. So what they did is perform some complex computational fluid dynamics, looked at redesigning the airflow around the vehicle, and said, how can we kick up more of that distribution of air so that it's not having such an impact on the car behind? And what they found by re-architecting it is that they were able to cut it down to around 7%. So you've got a drastic decrease in the impact of that airflow from the car in front to the car behind, which should enable a much more exciting racing experience for their fans. And all that was enabled by the fact that they could elastically compute this on AWS using these C5N instances. But what's key to many of the workloads that we see performed on C5N is not just the 100 gig raw network throughput that customers are achieving there, but also the fact that it enables our Elastic Fabric Adapter. Elastic Fabric Adapter is our own proprietary high-speed interconnect that allows scalability and lower latency. So previously, you saw on that one slide where I had, the latency had dropped between C5 and C5N from, say, 60 to 50-ish microseconds, and we routinely measured down in the 40s and 30s even. But it's not consistent. And what EFA has allowed us to do is, by creating this new protocol, is to really tighten up the bands so that now you're seeing a more consistent around 15 microseconds of latency. So you're getting a much tighter performing window for your network interconnect, which HPC workloads often demand. While some high throughput computing workloads are not as sensitive to that jitter in network latency or the inter-process communication between nodes, many of our workloads are, and that's why we've seen many customers that previously had thought their workloads may not even work on AWS, now with EFA on C5N, successfully complete those workloads. And one of those extremely demanding workloads that we kind of talk about as the granddaddy of HPC are weather codes. I alluded to it earlier, but oftentimes it is crucial to have an accurate, timely forecast. And one of our customers that's really benefited by using HPC on the cloud has been Maxar. And what Maxar does is take the standard NOAA weather codes, and they say, how can we complete those weather codes quicker than NOAA could? How can they do that? Well, they're not constrained by a fixed hardware infrastructure. They're able to fan out that workload to as many nodes as they want to, and then once they're done with that code, shut it all down, back to nothing. And so what they found by using that fan-out technology is that they were able to calculate the same NOAA codes in a third of the time. So think about the business impact of that. If you can tell your customers, if they're advising them, what the weather impact is going to be much quicker than anyone else knows the public weather predictions for those areas. Another area, again, that we saw customers saying we had to do better on when I started was storage. While some customers were happy with EFS and just running NFS over EBS, many said, I've got to have a more performant file system. I've got to have something that works in the way that I expect an HPC file system to work. And so as we, again, looked at storage systems and thought about how we could really provide something that gave value to our customers, we came back to kind of the granddaddy of file systems, and that's Lustre. Lustre has been a workhorse for POSIX-compliant workloads throughout the HPC community for several years. And so we said, how can we stand up something like Lustre, but do it in an Amazon fashion that provides that same elasticity, that provides that same value, that kind of changes the way people even think about storage. And in a typical storage fashion with HPC, you've got your racks of drives or SSDs, you install Lustre, you set it up, and you've got your scratch space or whatever, and you just run until drives fail, you replace stuff out, and then maybe over 3 to 5 years, you gradually replace racks of hardware. But it's running constantly. So what we thought about is, what if we made that dynamic and elastic? What if we said, okay, maybe today you need 200 terabytes, maybe tomorrow you need a petabyte. Why should you spin up a petabyte and leave that running for weeks? Make your storage fit your workflow, not make your workflow fit your storage. And so what that allowed is our customers now can, again, like stand up a Lustre file system, keep their data sets on cheaper S3, hydrate that into the POSIX-compliant file system, expose that to their workloads, perform their work, save off the data sets back to cheaper S3, and then shut the file system down. And they're only paying for that Lustre while it's up and running. This has allowed our customers to do some quite dynamic things. And then now we've talked about compute, we've talked about network, we've talked about storage. How do we put it all together? Again, one of those things I heard from many customers was, it's just a lot of work. It's totally different from the mindset I have of how I set up when I roll in my racks of hardware into my data center. Help me understand how I should think about orchestrating my HPC cluster in the cloud. And so we came up with AWS Parallel Cluster. This is built on the open source project CFN Cluster. What happened, we jointly started that several years ago with Intel and got lots of traction, but there was always this question, this is some open source kind of toy project. Do you really stand behind it, AWS? How should I think about it as a customer? Are you really going to help me if I have an issue with this? Because obviously an orchestration system can have catastrophic consequences if I set it up wrong, wind up losing data, something like that. So we said, okay, we're going to rebrand it. And we changed it to AWS Parallel Cluster to show that the full support of standard AWS contract falls behind that. But we also wanted to keep its open source roots, so it's still an open source project. You can go to GitHub right now. You can see the ongoing development that's happening right now. You can see the latest commits. You can see our release that we just had at Supercomputing a couple weeks ago with Slurm 19 support, as well as DCV integration for remote visualization. So we really think it's got the best of both worlds. An AWS product, but built on open source technologies. The two areas that we see the majority of our customers benefiting from by moving their HPC workloads onto AWS are scale and agility. I talked a little bit about the agility earlier with Lustre. Let's focus on scale a little bit now. One of our customers, Mobileye. Mobileye creates the little cameras, as they like to say. We're the ones that make that annoying beep, beep, beep sound when you think you're going to run into something or in your parking garage or you're next to something in your vehicle. They've got contracts with many of the automobile manufacturers to provide that visual sensor that gives indications of where the car is in space and provides safety recommendations. Now, one of the things that they're looking at doing was moving from kind of a 1 to 3 camera setup to a full 12 cameras around the vehicle, full HD setup. So think about the jump in data when you go from 1 camera up to 12 cameras, all being streamed, all being analyzed. And what Mobileye needs to do in their development shop is when they're looking at different algorithms and trying to really refine how they're advising vehicles, right now making suggestions for all of us as we're driving, but in the future driving fully autonomous vehicle interactions. What they want to do is say, okay, as we're updating that algorithm, now let's go simulate we just drove 1 million miles, because obviously they don't have time to go out and take a car and drive it around for 1 million miles to make sure that they didn't screw anything up. So as they're doing that, they want to make sure that not only are there any, okay, we didn't stop in that crosswalk when it looked like a person was going to step into it, they're also looking for any false positives. Okay, was there a time where we slammed on the brakes when there wasn't anything around? And so what's been key to them being able to continue to innovate at the rapid pace that they need to support their customers in the automobile industry has been the sheer scale of being able to dynamically go up to tens of thousands of cores, run until their workloads are done, and then go down to 0. And they've got some pretty impressive statistics of how quickly they're able to ramp up, run their workloads, and ramp back down. And what's exciting for them about it is they're only paying for that usage. So if they were previously in an on-prem constrained environment, they would have to build out for a system that was at that peak or else slow down their pace of development and testing. So we've talked about the technology challenges that many of our customers felt and how we've made progress on those. And now I want to quickly talk about a couple of the operational requirements and how we've made improvements there. And Barry will get into cost and cost management later, so let me focus on the first two, data. Many of our customers said, okay, I see you're performant now. I like your network storage, compute. What about my data? Why should I trust you guys with my data? And you can see up here the slew of resources that we've created to allow customers to ensure that their data is safe, whether it's the safety of applications running in their area, whether it's AI machine learning codes scanning their systems to see if any policy violations are in place. We've given you the tools with whether it's ranging from Amazon Macie to Amazon GuardDuty, all the ones you see up here, for you to put the policies and controls in place to ensure the security of your data and your customers' data. Okay, so then the question is, that's great. Now, how do I get my data into AWS? And probably the key to the vast majority of our customers' workflows are that inexpensive object storage on S3, and then even aging it off later to S3 and frequent access. So customers are looking at, how do I pull things into S3 from my on-prem storage? And we've got a variety of solutions there, whether it's the snowball, snowmobile, where we park a trailer outside for some large customers, but that allow you to have that data in your data center, plug it in, transfer it, ship it back to us. We put it into S3, and it's there for you. We've also got the synchronization options, whether it's AWS Data Sync, built on Storage Gateway, and now we're going to have to look through how do we integrate that all with AWS Outposts. So as you can see, there are lots of options to get the data into S3. And then once it's into S3, you can hydrate that into your FSX for Lustre, for those file system workloads, or you can operate it as you want with object-based interactions. You can perform AI and machine learning training on it. As you can see through all of this, we've had customers that have really benefited from the improvements we made over the last couple of years. And those have been all the way from high performance, high throughput, low density, high density. There's a whole gamut of customer workloads. And you see a few of the names up there. And what we'd like to stress is that we really feel like now we've got a portfolio of products to meet your needs. And what I'd like to do now is introduce one of our customers to talk a little bit more about how she and her company have specifically integrated AWS into their infrastructure. Alison Gorman-Nochdal from Morgan Stanley.
Thank you. So Ian mentioned his son, and I was going to share the little story. So my son is in college. When he was getting ready to go to college, kind of his junior year of high school, he looked at me and he said, Mom, I'm really interested in computer science. I really like it. And I said, great, that's what I'm in. I'm so excited that you share my interests. And he said, Mom, all you do is talk on the phone and read email. And basically that is what he qualified my career as. At which point I just wanted to share with you, there was a time and place where I did more than that. I started at Morgan Stanley as a mainframe developer. I ran enterprise computing, where I actually built and operated our internal grid, which is one of the key things I'm going to focus on talking to you about today. And then I spent 3 years in our security platforms team. Came out of that, took over cloud. And I'll tell you, when you have to be responsible for cloud and enterprise, your years in security are pretty much the primary qualifiers. So I'm going to talk a little bit about the business problem that we have. When you're a bank, one of the main things you do is figure out your risk. You spend oceans of compute trying to figure out every day where you stand with respect to your positions and balances and the overall risk that the firm is taking. We have kind of 3-ish scenarios that we deal with as it relates to running risk. The most important is that we literally have to finish certain calcs by the end of the day from a regulatory perspective to close out our books. If we don't do that, we get fined. If we get fined, people are unhappy. We close our books. The other thing we do is actually kind of cool because it gives us an opportunity to explore new business opportunities. So we'll do a lot of ad hoc runs and simulations. Our strats will run procedures on top of that data. And the more capacity we have to do that exploration, which is obviously very bursty, the more opportunities we can explore, and we can kind of fail fast from a business perspective. And then the third thing I always put into the category of things that are planned, semi-planned, and unplanned events that might otherwise cause us to have to do more or less risk calculations. So that could be something like an election, which you know is coming. It could be something like the results of an election that you didn't really expect. It could be something like Brexit, again and again. And it can be something like Sandy, which we kind of knew was coming, but we didn't think was going to wipe out the vast majority of the exchange for multiple days. And so planning for those bursts is really complicated. And when you factor onto that, the regulators are constantly adding requirements. We recently had regulations come out of the UK, which were something called FRTB, Firm Risk Trade Book, that essentially doubled the number of calcs we have to run in some cases. And while we knew that was coming for over a year, the multiple meetings and discussions planning how much capacity we were going to have to add, and knowing because it required new data center space, we had a 6 to 9 month lead time on the bulk of that, and knowing the application hadn't even been written, so we were really guessing at the capacity requirement, is actually what drove us to the cloud. We had started on the cloud many years ago, but what we found, and I think that was really a trigger event for us, was that between the burstiness, between these situations that we couldn't really predict very well, having an outlet, having an opportunity to take those calculations into an environment that we could use on demand was going to be really valuable for us. So there's a couple different workloads that we're moving, and they're all kind of different sizes. And they talk a little bit about how we're leveraging the cloud technologies. We were, like many people, we started simple. One of our simplest workloads is, think about it as just a little calculator. It grabs its data, and we were able to use the integrations that AWS had already done with IBM Symphony, which was our internal scheduler, to very easily start to migrate that workload and leverage technologies like Spot to keep the price right. Because I'll tell you, when you're an enterprise our size and you run your own grid, it's actually quite cost effective. And so that price parity is a big part of the conversation, and I'll come back to that. So that kind of paved the way. And we said, OK, we can do that. So we're going to take another workload that looks like that. It's a little bit more complicated, has a little bit more sensitivity and storage requirements, basically the equity space, which are pretty straightforward kind of calculations because it's a pretty simple portfolio. It's a big portfolio. And we started to move that forward, and we've had a lot of success, and we're in production parallel. So that was a huge accomplishment. And with that kind of under our belt, we said, OK, well, let's go do something harder. So we moved on. We started looking at our fixed income platform. Now, internally, we had actually built what we like to call a very opinionated platform. We wanted to have a lot of consistency for the developers because there's hundreds of strats that develop against this data set. And we wanted a lot of consistency in the way that they interacted with the data so that we could manage the entitlements and the access patterns. So we actually built a platform that handled that data access layer. Conveniently called it the DAO because we're super creative. And then we actually also built a layer of software that it could run on top of. And so when we looked at the cloud and we said, well, we really want to take that with us, Kubernetes sounds pretty cool. And we're working in partnership now with AWS to get EKS enabled to let us actually take those workloads into the cloud. And that is actually probably one of our biggest workloads. And then if we look forward into kind of past 2020, maybe late 2020, the solutions that were discussed today, things like Lustre, things like 100 gigabit internet networks, start giving us an opportunity to move workloads we never thought we could move. So our credit risk valuation is actually an application that was written with like a pathological fixation on one file. We have to run a parallel file system on the inside of our environment and a very high-end network. And so when we looked back early days, and actually when we first started working on AWS, we were seeing things like TCP exhaustion, I think Ian alluded to. Those upgrades that were done were really critical for us. And so now we're really looking forward and in partnership with AWS, thinking about how can we move these more complex workloads and potentially get the cost efficiencies and also the de-risk of being able to run them much more quickly. And the simplicity of getting some resiliency that we wouldn't otherwise had, which kind of takes me to partnerships. So back in 2012-ish, probably, when I was running our grid, everybody got like all excited about the cloud. Allison, we got to go to the cloud. There's this thing in the cloud. We got to go. I said, great, call AWS. I said, hi, we're a bank. We need to use you. They said, oh, OK, cool. So what do your contract terms look like? I said, well, if we lose your data, we'll give you like 3,000 in credits. I said, OK, I'll call you back in a couple of years when you figure that out. And they did. So when I came into this role about 2 years ago, we were actually in the throes of closing a very complex contract negotiation. We continue to kind of hit some things as we go. But the partnership is there, and the understanding of our business is there. So from a commercial perspective, I'd have to say cloud industry in general, and certainly our partnership with AWS has grown massively. Turning from there to security, obviously a sweet spot for me, we have seen a huge appreciation for the challenges we face, and we no longer have people saying, why do you need that? We have people saying, how can I do it with you and for you? And then getting leverage off what other customers need. Looking at the technology, and I can't do justice like Ian can, but one of the things that's really exciting for me is straight infrastructure as a service is kind of boring. And so starting to see some of these platform services where we can start to decrease our engineering efforts and lean more and more heavily on services that work kind of out of the box, hygiene that's evergreen for us is extremely valuable. And it really helps with the last piece, which is how much does it all cost, which is kind of what you care about when you're a bank. And both the combination of the increasing price per performance enhancements that we're seeing, as well as the partnership that we're seeing and kind of understanding what our numbers need to look like and work with us, and how technology can be changed to meet those financial needs as well, has really helped solidify that partnership. And with that, Barry Bolding is going to come up, the Director of Business Development, and talk to you about, I believe, some of the things I alluded to.
Yeah. Thank you, Allison. So you've heard the story of the innovations and the growth in the technologies that we've had over the last
2 years, 3 years. The degree that we've focused on HPC and improving the infrastructure, improving the tools that we provide to you. You've heard a customer example of how they have used those tools, how they have rethought how they can do their workloads and integrate their applications into a new type of environment, and an environment that is less constrained, that doesn't have a fixed infrastructure that they're trying to build across. And so I'm gonna take that and I'm gonna talk in general about how we work with customers to rethink their problems, rethink their applications. And if you're going to take advantage of the cloud, you have to begin to think outside the bounds of those constraints. And this is what we try to help our customers do. I've been in the high-performance computing business most of my adult career. I'm very familiar with the infrastructure, and designing applications that have to fit a given infrastructure is a constraint that we've always had to live with in the on-premise world. And what's exciting about AWS is that now we can talk to customers, and instead of designing their applications to the infrastructure, we can talk about the workloads and talk about how the customer can design their workload and design the infrastructure for each workload in a particular way. And it's really a powerful paradigm. Ian alluded to it quickly when he said, some applications might use C5N, some might use FSX. The FSX can grow or shrink. But what we want to do is take that to its ultimate end, which is the complete redesign of thinking around applications. I'm going to give you some examples of that. When you start doing that, you start looking at what are the paradigms that I live within in a cloud world. Well, infrastructure is important, and so you have to make a lot of choices about infrastructure. And the nice thing is you're going to be able to make multiple choices. So if you have a CFD application that you run, you can make certain choices. If you have another type of risk calculation or Monte Carlo calculation, you can make another choice. So I'm going to talk you through some of the choices around infrastructure. Another choice you have to make is scale, which is how wide or how deep do I want to take my application? Because now you are outside the bounds of that fixed cluster that you used to have in a closet. And then you have to map the pricing structure to this. And so there's various ways that, because cost is always important, especially for a bank, as we heard. You have to map, okay, if I go deep or I go wide, what's the impact? If I need it tomorrow versus I need it a week from now, what is the impact of that? And how do I make the most efficient price-performant choices? And then ultimately, agility is an area where we see the most customer interest. And agility is about how can I bring new technologies to bear that haven't really impacted me yet. We're seeing more and more customers ask, how can I have a workflow that incorporates machine learning and then simulation and then machine learning again? In the autonomous vehicle space, we had an example from Mobileye, but there are many autonomous vehicle companies that we work with, and their typical workflow is to take data from a car, to train to the data that they're getting from the car, then to do millions of miles of simulation. And so that agility of combining resources that you used to not to be able to combine in a fixed infrastructure is very important. So infrastructure choice. This is where you can take the first steps in simplifying this choice of 270 features or instances. And in HPC, we do see that there are choices that are very commonly made based on the base requirements of memory bandwidth, memory capacity, CPU clock speeds. So the choices of whether to use M instances for memory capacity, C instances for their general use and ubiquity and volume, GPU-based instances, that choice to use that for training or to use that as a compute acceleration engine. We see that often, for instance, in the seismic space, where we have customers that have optimize seismic workflows to use GPUs as a vector accelerator, basically. And so they have to make choices about those infrastructure. And the really innovative thing about the cloud is that these choices you make are not fixed. These choices about infrastructure evolve every day. And in partnership, that partnership part of the engagement with AWS is that we'll talk to you about what evolutions are happening. This year we announced several evolutions in instance types, almost revolutions with the Graviton 2 chips and instances that we now are incorporating into AWS, and the AMD instances, and the various GPU instances with P3 and G4. Those choices will give you performance choices, price choices that will evolve over time, and you can continually innovate on that infrastructure. You don't have to stay fixed for 2 to 3 years. In terms of scale, this is a really interesting one because if you break the bounds of those constraints, you can start thinking about how do I accelerate my workflow in a way that would never have been possible. We've often talked about an example from Western Digital where they were designing hard disk drives. Of course, Western Digital makes hard disk drives. And they look at the electronic interference of the various components in their devices. They had workloads that typically on-premise would take on the order of a month. And they started asking the question, because this is tied tightly into their design cycle, if I look at a cloud-based re-architecture of the problem, and I use some of the pricing models and the infrastructure models and the orchestration models that are available, such as using Spot and grabbing a very large volume of compute instances, can I rethink the problem? And now there's an orchestration problem here. I now have to think about spawning literally a million processors simultaneously to work on the problem, which shifts the problem away from, here is a simple orchestration problem that I run for a very long period of time, to a complex orchestration problem that I want to run for a very short period of time. And they managed to take this workflow down to 8 hours, and about 30% of which is actually just grabbing a million processors and getting those ready and getting the jobs launched. So that really is a powerful paradigm. We're seeing the same paradigm in the seismic space where oil companies are starting to say, instead of looking at seismic workflows as a single part of a puzzle, that's my HPC part, they're saying, well, HPC is really the whole 9-month process of getting data off of a ship, taking that data into a data center, doing a set of image analysis, Fourier transform type algorithms to get an image off of this raw seismic data, and then decide whether to drill a well or buy a parcel of land. And if they look at the whole workflow and they begin to say, can we take the piece that used to take 3 or 4 months, do this seismic analysis, and I can stream data in and start doing seismic analysis while the ship is still out on the ocean, then I can begin to compress that workflow from 9 months. Maybe I can get that to 6 months. Maybe I can get that to 3 months. Maybe I can get that to a month. And the value, the business value that they generate through that is not measured in millions of dollars. It's potentially measured in billions of dollars. In terms of then the next step, okay, I've rethought my architecture. I've rethought outside the bounds and constraints. What tools is AWS providing to me to be able to do these simulations, to do these workflows, and then do those in a cost-effective way? Because price performance value, a business value for the compute is critical to us all. And we provide primary mechanisms. We've kind of revamped the reserved instance model, which is your baseline compute model with the savings plans that allows the customer to use different instance types. We're continually innovating on that to try to make that a more robust and flexible infrastructure. It's no longer an infrastructure that's like you're on-premise. It's reserved. You only get one instance type. That kind of looked like on-premise. With a savings plan, it now looks like a very fluid type of model where you can reserve a certain amount of compute, but you can begin to shift various workloads into that reserved instance. And then on top of that, of course, for high value, I need the data tomorrow. I've got to have it. I need it now. On demand is, of course, our primary tool there. And then we introduced Spot about 1.5 years ago, and that's really continuing to evolve. With Spot, we're continuing to add more and more innovation with Spot Fleet. We work with customers to design those architectures very carefully because it's important to understand Spot is a resource for cost effectiveness, but not necessarily, you could lose the ability to access the nodes that you're trying to get. So you have to have built-in resiliency. It has to be applications that can survive losing a few of the instances that you've requested. And so we work closely on best practices with our customers so they can rethink, oh, well, I don't want to work on just one availability zone. I want to have the ability to grab instances from multiple availability zones. And so as we continue to innovate on Spot, you can add that to that repertoire of price performance optimization. And then ultimately, this gives the power to you to trade off time to solution and value to your business against cost effectiveness and value to your business in that respect. And so you get to make that choice of what's important and how much should I pay for it. A lot of times we hear, well, it's nice to have good cost-effective models, but still I'm a researcher, I'm at a university, or I'm at a company, and I have a budget, and I'm not quite sure. I'm a little afraid that if I start this job, if I run this parallel cluster job, and I spin up, 400 or 500 instances, how much is that going to cost? Because I have this fear that I can suddenly expend up most of my yearly budget, and not be quite sure I'm going to hit that. So we continue to innovate on the cost management side. We've launched a number of innovations with the AWS budgets and the AWS Cost Explorer, which provide you APIs to be able to look at the costs that you're generating. We also work with partners. In the HPC space, we have a partner called Ronin, that came out of the CSIRO, the academic community and the government community in Australia. And when you work in the government communities or academic communities, you have these grants and budgets. And they built some tools on top of AWS that they've since productized that allow them to actually do cost prediction for and to be able to categorize based on grants. And it can give the power to the department head to be able to see if the grant researchers are hitting their budgets, or if they're getting close to 90% of their budgets, they can put a pause button on that researcher, or get a warning flag that that researcher is beginning to reach a point where the cost is getting close to exceeding their budget. And it's a powerful tool, and you're going to continue to see innovations like that. We did that demo. Ronan was actually in our booth at Supercomputing, had a lot of activity as customers were coming by and seeing how they had implemented this, how they had built parallel cluster libraries underneath this tool so that you could run your molecular dynamics code, you could run your quantum chemistry code, you could run your autonomous vehicle simulation, all underneath of a very simple web interface. And then finally, agility. And there are multiple types of agility. This really depends on the workflow you have and what's important to you. For some companies, some businesses, some universities, the agility is really about being able to rearrange the workflow a little bit. It's really just rethinking, okay, I can be doing post-processing at the same time that I'm doing the simulation because I now have access to additional, a vast cloud that I can do work. So you're not constrained to the box, as is shown on the left there, the box of an infrastructure, an on-premise infrastructure. You now have a very elastic environment where your use of those resources just depends on how you need to grab those results and how your resources are available. Are they 8 to 5 when the engineers are in the office and you need lots of resources. You need your visual desktop. You need to be doing computational fluid dynamics simulations to design the toaster that you're working on, or to work on the ship design. And so you can accommodate all of those cliffs and valleys, and you can rethink how your business is agile. But the more exciting part of agility, I think, as someone who's been in the HPC business, is the ability to combine learnings from different workflows that you're seeing. And one of the values that we try to provide as an HPC community within AWS is to transfer learnings from financial services, where we see a certain characteristic of simulation and modeling, to other workflows, such as seismic and reservoir, or from autonomous vehicle simulations. And what we're seeing now is really a collective increase in the knowledge about how to utilize all of these resources. And it really shows up in the area where machine learning and AI is being used across these different domains. And we see the same question being asked by financial services companies as are being asked by engineering companies or seismic companies. So in the seismic space, for instance, we have a partner that is working, a partner, Blueware, that works with our seismic companies. And what they're doing is building machine learning algorithms that can look at subsurface images that you're getting from a seismic analysis and identify salt deposits, which was always a very manual process. You'd have a seismic engineer identifying salt deposits based upon the characteristic shapes that you have when you get the images back. But if you can incorporate machine learning into that, you can again compress the workflow. And it's a very similar type of analysis that can be applied to any one of a number of HPC applications. So workloads across industries, and really the word I want to emphasize here is workload. So every industry, automotive, has workflows, some of which are computational fluid dynamics. Now it's autonomous vehicle simulations. Those are very different workflows, but they sit in an industry. The way we look at HPC at AWS is we look at workflows, and we look at workloads, because that's where the transfer of knowledge can really be enhanced. So I want to talk to you, I think Ian talked about the Maxar example, which I think is a really amazing example, because in my previous life, in the on-premise world, it was believed weather and climate simulation, or especially weather prediction, weather forecasting, or NWP, was really an on-premise domain. That the cloud was not an appropriate place to do weather forecasting. And so what we're seeing by this evolution is that there is no workload. I can't even imagine a workflow today that cannot be done on cloud. There are constraints. Moving data off a ship to getting into a data center, that's a constraint. If you can't overcome that constraint, then you may have some issues. But those are going to be solved. Those are not technical blockers. They're just hills. They're hurdles that we have to overcome. And so that's really exciting to me, is to see companies like Maxar really taking advantage of the technologies we have. Another example is in the life sciences. And so the Fred Hutch, it's exciting to see, in the medical area, to see such advances. The Fred Hutch and the Seattle Cancer Care Alliance in Seattle are big research centers that are trying to solve the problems of cancer research. And so the Fred Hutch actually has been doing some really interesting research here. And they've been doing research on cancer vaccines, which can basically, how can you put people into remission, or once people are in remission, how can you train their bodies to keep them in remission? And that led into another set of research where they were saying, okay, what other ways can we train the body to fight cancers? And they started looking at the microbiome of the body. And the microbiome, basically, there's hundreds of thousands of organisms that live inside our bodies. Can we train those organisms to fight certain types of cancer? And much like, we have cancer vaccines today. And so they were doing research where they were basically taking hundreds of thousands of simulations of these samples, and because of the scalability, this elasticity or scalability, they were able to compress down the workflow and begin to get results instead of 7 years with the resources they had on site and on premise to start just completely redesigning their workflows and basically use that scalability and agility of the cloud and do that in days. So that's really what we've designed AWS to be, is that HPC resource. In terms of HPC maturity, it's exciting to me to see that with all these great technologies that Ian's team have been developing, that we're beginning to see that people are coming to us and saying, okay, I want to really understand how to redesign my application. At Supercomputing a couple of weeks ago, the flagship conference for high-performance computing, much smaller than reInvent, about 15,000 people instead of the 50 or 60 or 70 that we have here, but 15,000 focused folks on HPC. AWS was proud to be awarded 6 HPC awards. This was 3 times more than all the other cloud vendors combined in terms of number of awards, but more importantly, awards like best cloud platform and best new technology with the Elastic Fabric adapter, and it just shows that customers who really understand HPC are beginning to see that the cloud, AWS, is building an HPC environment that they can begin to think about their problems without these constraints. Think about how to build and redesign their applications and really take advantage of a world in which they don't have to live in a box. I think I will close out. Again, the challenge I pose to all folks of the HPC community, and I came from being a scientist in the HPC community, so a challenge to myself as well, how to rethink all of these problems that we've traditionally looked at in a very constrained manner. I want to thank you guys for your time. I want to remind you to complete your session survey applications, but at that, I just want to thank you again.